By 2035, the lunar South Pole is scheduled to host the initial components of a permanent research facility. China is currently designing the International Lunar Research Station as a network of active modules, using thermal cables and roving vehicles to link the site together under the power of a central reactor. This approach contrasts with the last 50 years of lunar exploration, which relied on short-term, expensive visits. Those missions functioned as isolated events, leaving crews completely dependent on Earth for every kilogram of resupply. Building a permanent settlement requires overcoming environmental threats that the Apollo missions never had to endure for more than a few days. Settlements must survive 14-day freezing nights, abrasive moon dust that destroys machinery, and the extreme costs of shipping survival gear across the vacuum. To bypass these hurdles, China and its international partners have drafted a step-by-step architectural plan to deploy the ILRS infrastructure by 2035. Transitioning to a permanent base requires a multi-system rollout. It moves the mission focus away from the constraints of a single, massive launch toward a continuous pipeline of smaller, interconnected deliveries. The first logistical hurdle is capacity. Building a station requires delivering heavy construction cargo and human crews to the lunar surface at the same time. China's solution involves a dual launch architecture. Instead of one massive rocket, the mission is split between two separate Long March 10 boosters. One rocket carries the astronauts in the Mengzhu crew capsule, while the second launches the 26-ton Lanyu lander. Both vehicles dock in lunar orbit, allowing the crew to transfer into the lander. During descent, the Lanyu propulsion module shaves off the craft's speed, then jettisons just above the surface to lighten the load for a soft touchdown. This hardware is being tested for a 2030 crewed scouting mission. Success there will be followed in 2033 by the Long March 9, a super heavy rocket designed to lift 150 tons of cargo to orbit. Mastering this dual launch rendezvous and deploying heavy lift rockets creates the logistical pipeline needed to shift the program from simple scouting to full-scale base construction. To make the base sustainable, missions must utilize local materials, a process known as in situ resource utilization. This removes the need to ship every liter of water or beam of steel from Earth. The resource search begins with Chang'e 7. It features a specialized hopping probe designed to launch sunlit rheas into the absolute darkness of shadowed craters. The probe is hunting for water ice. On the Moon, ice is the most valuable resource available. It can be processed into breathable oxygen for the crew and liquid hydrogen for rocket fuel. The 2028 Chang'e 8 mission will test technologies needed to physically build the station, including 3D printing structures using moon dust. Engineers plan to use high-power lasers to melt lunar regolith into interlocking bricks, which robotic arms will assemble into shielded habitats. Locating water and mastering 3D printing transforms the Moon from a barren environment into a self-contained supply chain. Survival on the South Pole depends entirely on energy. During the 14-day lunar night, traditional solar panels are rendered useless, and battery storage alone cannot sustain a permanent base. To solve the power crisis, China and Russia are collaborating on a lunar nuclear reactor. The target is to activate the system by 2035 to guarantee the station has round-the-clock power and heat. While the rockets and crew capsules are currently in active hardware testing, the nuclear reactor and the larger 2050 habitats are still in the conceptual phase. The current roadmap focuses on validating the basic model first. Linking these systems requires a constant data connection. China's Quick-Chow relay satellites orbit the Moon, bouncing communications from the South Pole back to Earth without interruption. Reliable nuclear energy and an unbroken orbital communication web are the utilities required to turn a temporary shelter into a permanent installation. The 2035 blueprint describes an integrated loop: routine heavy lift transport, local water extraction, 3D printed structures, and constant nuclear power. This timeline places China's efforts in direct competition with NASA's Artemis program, which is targeting the same resource-rich regions of the lunar South Pole. Today, the technical hurdle is industrial discipline. The strategic objective is defined by the ability to build the robotic systems required to stay on the surface, rather than the capacity to simply touch down and leave. The goal is an autonomous facility that functions even in the absence of humans. The 3D printers and reactors are designed to maintain the site, allowing the infrastructure to survive and expand while crews are in transit. China's 2035 architecture proposes a shift in how we approach the moon. It moves the site away from its history as a scientific finish line and toward its future as humanity's 8th inhabitable continent.